Free fall. Free fall means that when the body moves freely and the body is free to move in any way, so that it moves only under the influence of the gravitational field and all resistive forces are absent, then this kind of fall or this kind of motion is called the free fall. So in Newtonian mechanics, any kind of motion of the object taking place under the influence of gravity of Earth only is called free fall. It means that all the resistive forces must be absent. In free fall, all resistive forces like friction, viscous force, drag force, etc. are absent. So the body is moving only under the influence of the gravity. So now what we have? That this is now body. This is falling vertically downward. This is now weight or the gravitational force on this body, and it is moving in this direction. So the force equal to weight of the body. It means that this F is equal to mg or F minus mg equal to 0. So this is necessary in case of free fall. Or this ma equal to mg or a equal to g equal to 9.8 meter per second square. This is not so much. So when the body falls freely, then its acceleration is equal to the gravitational acceleration. This free fall does not mean that the body moves with a constant velocity, but the velocity changes continuously. In free fall, the velocity of body is not equal to 0. So the velocity of body increases such that its acceleration is equal to the gravitational acceleration. As I have told you here, that when the body falls freely, then its acceleration is equal to 9.8 meter per second square. So this is where this is what that we have said. This the velocity is not constant, but this moves with a such velocity. The velocity changes in such a way that the acceleration is always equal to the gravitational acceleration. Truly speaking, the free fall is possible only in vacuum, because in vacuum there is no drag force or no viscous force or no friction, so the body falls freely. So in case of the vacuum, all the bodies have the same gravitational acceleration. In vacuum, the bodies of different size and shape reach the ground in same time when dropped from same height. It means that when the bodies are of the different shape and different size, or this is a different mass, even all the bodies which are falling from the same height, they will reach to the ground at the same time. So the time of reaching to the ground or the time of reaching to at some destination in the free fall, the time will be equal to the same. in general theory of relativity. Free fall means no force acts on the body moving along geodesic. Geodesic is in free space. So now when the bodies are very massive like the black hole and the other so many stars are there, then when the body reaches near to them, then this is under the action of the gravitational field. So only the gravitational field acts on the body. So because of that, the body is in the condition of free fall. The free fall is not possible in Earth's atmosphere due to resistance imposed by air. Now, Newton's laws are valid in case of when the body falls freely under the gravity of the earth. So there we assume that all resistive forces are absent. The equation of motion are valid in free fall. Of the body. When the body moves up, body moving upward, then we have this V equal to U minus GT, S equal to UT minus half GT square, and this V square equal to U square minus 2GH, and ST equal to U minus half G into 2T minus 1. So this is when this body and this body is moving vertically upward like this one. Body moving vertically downward. moving downward, then what we have? That this equation of motion V is equal to U plus GT and S equal to UT plus half GT square, and this V square equal to U square plus 2GH, and this ST equal to U plus half G into 2T minus 1. So this is when this is now body, and this body falls freely in this way. So when this body is falling vertically downward, then we are having these equations. So for free fall, the initial velocity is equal to 0. When the body moves freely downward, the initial velocity becomes equal to 0. So in this, the initial velocity U, this is equal to 0. Here ST is the distance traveled by the body in tth second. As I told you earlier in the equations of motion, when in my short video that you have seen. So these are the cases. These Newton's laws are valid only when the body falls freely under the gravity of the earth. So whether the body is moving vertically downward or vertically upward, all these are the cases of the free fall. So free fall does not mean that only the body is falling vertically downward, but the body moving vertically upward, that is also the case of free fall. Now the examples of free fall. Examples of free fall. Number 1. Falling off dewdrops raindrops ice balls the skydivers paratroopers paragliders this now you take the number 2 paragliders without parachute. Fall are in free fall. planets, or we can say the satellites orbiting astronauts, etc., orbiting the Earth. These are also in the condition of free fall. The planets orbiting the sun, these are also in free fall. Similarly, the weightlessness, now this weightlessness is also the case of the free fall. So there are so many cases of the free fall, and here we assume that the air resistance is 0. The following are not free fall. कौन कौन से फ्री फॉल में नहीं होते हैं? नंबर 1, moving in aeroplane, bus, etc. These are not the cases of free fall. Standing on the ground, this is not the free fall, because weight of body is encountered by reactional force, normal reaction. So this is not the case of free fall. Similarly, in case of this aeroplane and bus, etc. So all the moving vehicles, they are not in the case of free fall. And I have told you that when the paratroopers and parachutes third, the skydivers, paragliders, and the paratroopers etc. with parachute. अगर इनके पास पैराशूट है और ये पैराशूट डिप्लॉय हो जाता है तो फिर ये फ्री फॉल में नहीं आती। Which is डिप्लॉयड। तो जैसे ही पैराशूट खुलता है तो उसके खुलते ही उस पर रेजिस्टिव फोर्स एक्ट करते हैं और उसकी वजह से उसकी वेलोसिटी कम होने लगती है। So this I told you earlier in my video that this kind of motion is governed by only by the gravitational field or gravitational field of the earth. But in that case, when we are having this parachutes, then the upthrust force, the viscous force, all of them act. So because of that, this is not under the case of the free fall of the body. So this is what the free fall of the bodies. So thank you very much.